Okay, guys, today we're going to work on getting back in your memory how to change from an improper fraction to a mixed number. Now, we've spent some time today talking about vocabulary that has to do with this improper fraction. So remember, when we talked about an improper fraction, in a fraction, that's where my top number is larger than my bottom number. So it's top heavy. That number's bigger than this one down here. And the denominator, the number in the bottom, can't be 1. So here's an example of an improper fraction. Now we're going to come up with a strategy or a way to take that and change it into a mixed number. So a mixed number, remember, is mixed because it has a whole number value and a fraction value. So if we were going to solve this, we always have to make sure that we're able to go from that improper fraction to the mixed number using the same process every time. So as we talked about strategy earlier, most of you had a strategy that had to do with dividing. And the big thing for us to remember is it's dividing because this horizontal bar that we use right here stands for division. So if I were to look at this one right here, the improper fraction of 12 over 7, that's the same thing as saying 12 divided by 7. Now, one of the things that's built into every fraction problem that we do, they just expect us to do it. They're not going to always mention it. It's built into almost every problem. So if you have a fraction, they are always going to assume that you're going to reduce if you can. That means going through and taking out any common factors that they might have in common to make your fraction as small as possible. So we're going to work our way through some examples so we can make sure that you kind of have the strategy down again and it's back in the front of your memory. And also to be sure that you can kind of double check yourself and make sure that you've done it right. So on this first problem, I have 17 over 4. Or 17/4. So we talked about this is really standing for division. So that's the same thing as saying 17 divided by 4. So let's take this and kind of split this up a little bit. This is going to go under your division bar. So there's 17. And this is going to go in front of the division bar because that's what you're dividing by. So your 4 is going to go there. So I want to see how many times 4 is going to go into 17. So the closest you can get without going over would be 4. So remember, 4 times 4 is 16. And I would have 1 left over. So now remember, we're trying to get this into mixed number form. So as we went through, some of you guys, it helped you to use kind of that check mark method to make sure your numbers were in the right order. So here's my first number, 4. That's the whole number part of my mixed number. So if I keep doing my check mark method, it's going to go down here and go up there. So you can see how this looks like a check mark. So the first number you would go to is 4. That goes in the front. Next number we're going to go to is 1. It's going to go on the top of your fraction. And 4 is going to go in the bottom. Now, one thing that I always like to remember is that whatever number I divide by here, it's in the bottom of the fraction. It's going to end up in the bottom of the fraction here. Now, we did talk about remembering to reduce if you can. So if I look right here, 1 and 4 don't have any factors in common except for 1. And dividing them both by 1 won't change their value. So this is going to be my final answer. Okay, let's take a look at another one. So my next one is 15 over 2, or 15 halves. So this is the same thing as 15 divided by 2. So now remember, this is going to go under the division bar, and this is going to go in the front. So there's my division bar. 15's underneath, and 2 is out in front. Now I want to make sure I'm going to see how many times 2 will go into 15 without going over it. So the closest that I can do to 15 would be 7 times. Because 7 times 2 would be 14. 1 left over. So if I go through and kind of use that check mark method that we were doing before, it's going to go just like this. So the first number I touch is 7. That goes out in the front. Then 1 is in the top of the fraction. So you've got this number up here. And then 2 is going to go down on the bottom. Now remember, we said before, if there's a 2 in the bottom here, there should be a 2 in the bottom there. Those should be able to go right over. Now, we do need to check to make sure this fraction doesn't reduce. And 1 and 2 don't have anything in common. So there's my final answer. Okay, so let's take a look at the next example. So let's start to get numbers a little bigger. So I have 100 over 23. So that's like 100 divided by 23. This number goes under. This number goes in the front. So 100 divided by 23. Now remember, I want to see how many times 23 will go into 100 without going over. And the closest that it could do would be to go into 4 times. Now, if you have trouble with one like that, one thing I always think about is 23 is pretty close to 25. And 25 would go into 100 about 4 times. You can use those estimation skills to help you out there. Okay, so now let's start to go through and get things multiplied together. So if I were to do this, 4 times 23 is 92. And you would have 8 left over. So if I use the check mark method, it's going to be 4 and 8 over 23. Now, remember, we want to check the fraction, see if there's anything that can reduce. Now, 23 is one of those numbers. It's a prime value. So that means the only thing that goes into 23 is 1 and itself. So there's not going to be any factors that these two will have in common. So that's going to be your final answer. Okay, let's take a look at some that are going to require a little bit more of following through with that reducing on the end. So the next one is 48 over 14. So remember, that's 48 divided by 14. So that means this number is going to go under the division bar, and this one's going to go in the front. So there's my division bar, 48, and 14 in the front. Okay, so if I want to see how close I can get to 48, the closest I can get is 3. Now, if you're having trouble thinking about that and figuring out which one will be the closest that it can be, remember, you can always go through and put it in your calculator. So if I did 48 divided by 14, you can see on here, it gives me like 3.4, yada, yada, yada. So whatever number's in front of the decimal point is how many times it'll go in without going over. So we know in this case that it will go in there 3 times evenly. So don't be afraid to use Desmos or a calculator if you're getting bigger numbers and you just want to verify or check that you're in the right ballpark. So now if I go to multiply, remember I have to do 3 times 14. So 14 times 3 is going to be 42. So I'm going to have 6 left over. So I'm going to do my check mark method right here. So it's going to be 3 and 6 over 14. Now this is one I can tell by looking at it right here. I know they're going to have at least one thing in common because I can tell they're both even. So that means that we're going to have to take that fraction part and reduce it. So we have said before, if we know that it's even, that means that 2 would have to go into both of them. So if I reduce that, 6 divided by 2 is going to be 3. 14 divided by 2 is going to be 7. So if I look at these two numbers now, 3's prime, and so 7. So the only thing that's going to go into 3 is 3 times 1. The only thing that's going to go into 7 is 7 times 1. So you know that you're going to be at the point now where it can't reduce anymore. So this is going to go in for 6 over 14. So that means it's going to be 3 and 3 over 7. Okay. The next one I'm going to give you, let's try one more that's a little bit more of a reducing one. And then I'm going to have you try one on your own, a little bit of guided practice. So here's my next one. So 55 over 15. So if I go set this up, there's my division bar. So remember, this is going to go under and this is going to go in front of the division bar. So if I want to see how many times 15 is going to go in to 55, the closest it can get is 3. So 3 times 15 is going to be 45. And I have 10 left over. So if I do the check mark method, it's going to be 3 and 10 over 15. And remember, this part right here, I can tell by looking at it that 5s are going to go into both of those. So if I reduce them both by 5, it's going to be 2/3. So I'm going to put this in the spot where 10 over 15 is. Okay, let's have you try one on your own. So here is the next one. So 37 over 13. Okay, so I'm going to give you a chance right now. Write that one down to go through to solve it. I'm going to wait a few minutes, and then I'm going to go through and start to solve it so we can check to see if we're on the right track. Okay, hoping your first step looks something like this. Okay, hoping that you end up with 2 and 11 over 13. Now remember, we do need to check this part to make sure it doesn't reduce. Since 11 is prime and 13 is prime, they don't have anything in common, so that's going to be your final answer. Okay, now make sure on all of these, you have these examples in your notebook. And make sure that you go back and rewatch this if you feel like you're not really sure if you've gotten the skill yet or not.